I honestly don't think machines will one day replace human beings. That's a fear that's also a hot topic of conversation people have, right? Will machines replace human beings? I don't think it will.
Hello and welcome to a whole new episode of Engati CX. I'm your host Chandani and we're really glad to have all of you join us today. On this show, we talk to CX and tech experts from around the world. We explore, uncover, and share fresh insights on creating experiences that your customers will remember and look forward to. Engati is the world's leading multilingual, no-code digital CX platform available across 14 channels with 45,000 solutions created across 186 countries in every domain and use case. Engati has also been recognized as a top platform by Inc. magazine, Tech World, CIO magazine, and many others. We run the Engati blog, video channel, and the Engati CX podcast, receiving upwards of 400,000 visitors annually. And now for our guest, Bindu Narayan is the Senior Manager of Advanced Analytics and AI at EY. She is an analytics professional with a passion for mentoring and solutions. What drives her is developing analytic solutions and products with a clear market value proposition. She believes there's a lot that organizations can and should do with data. She specializes in team management and delivery, predictive modeling, statistical modeling, and machine learning. Welcome to the show, Bindu. We're really glad to have you on today.
Hello, hi. Nice of you to have me in the show, Chandni, and thank you for the opportunity.
Thank you for coming on the show, Bindu. So, before we dive into our interview with Bindu, don't forget to subscribe to Engati and tap on the bell icon to get access to exclusive content from thought leaders around the globe. So, beginning with the interview, Bindu, would you prefer being called an AI leader or a data science leader?
Data science leader any day.
And why is it so?
Because data science, in my opinion, is a superset of AI. And the way AI is perceived and the way AI suddenly became visible to the world, the connotation with AI is more on cognitive computing. So when I say cognitive computing, it's a branch of data science which specializes on building algorithms which think and act like human beings. That's what cognitive means. Okay. And that's got more to do with unstructured data, which is pictures and videos and audio clips and images. Okay, and then that's where the most people connect AI with. Whereas I am personally from the other side, like I learned data science from the structured part of the data. Well, now comfortable with both sides, but the word AI kind of restricts your understanding to that one section of the world only. Whereas, in my opinion, data residing in an organization is not always pictures and videos and audios. If you have to run your business, you have to start with numbers, you have to predict sales, you have to understand transactions. Those are all in numbers. So, which is, and data, the word data is fundamental to what we do in the world of data science. So, I prefer to be called a data science leader than an AI leader.
That's really well said. And as you said, data is not just pictures, but numbers also, and it is very important to keep a track on those also because it's very important to measure those metrics when you run a business. Absolutely well said, Bindu. So, moving on to my next question, we hear a lot about explainable artificial intelligence. Why is that artificial intelligence is deemed to be unexplainable in the first place?
Okay. So again, this has got something to do with the origin of AI. I will step back a little bit, and I told you my learnings was more from the structured side, right? So 10 years, 15 years back, when we all started, like when I started my career as a data science, this buzz of AI was not there so much, like nor was machine learning too much heard about, even though that stream is pretty much old, and that's a stream of computer scientists. Machine learning is more a domain of computer scientists, whereas statistical modeling is a domain of more mathematicians and statisticians. So during those days, the algorithms that we used was pretty explainable, to be very honest with you, right? So in my PhD thesis, I did PhD around customer satisfaction modeling. I used a technique called structural equation modeling. It's very, very easy to explain that. And I'll come back to structural equation modeling in a different context. Uh, but there are still algorithms which are very explainable, right? It can be written in a type of an equation or a series of equations. And just to name some of them, linear regression, logistic regression, decision trees, structural equation modeling that I talked about, are all explainable. What it would need is a data scientist who can convert the math into English and explain it to a business audience. Okay. So in my 15 years of career in analytics, uh, this is one of my roles and responsibility as a senior manager, to explain some of these models to business in plain English, which I have realized, like, somebody junior a lot of times is not able to do. So mostly I'm called in to explain these to a CXO audience where you have to explain it in English. So it has to be a data scientist who is equally conversant with math as well as, I'm not saying English, common business language, whatever the language is. Now, I can explain it in Hindi also. But somebody who can translate that math into a business language is all that is needed to convey this message to a business audience. And a business audience who has a elementary understanding of mathematics should be able to grasp it. And I have found that most CXOs, most people at executive level, has the depth of understanding, and it's very easily translatable to them. So it's not totally unexplainable. There are still algorithms, and the things that I talked about are still very much in use. They're very powerful and they're very much in use. There is a section of algorithms properly explainable. Okay. But why this sudden interest in explainable AI is also because of a specific school of algorithms that came up through computer science world called neural networks or artificial neural networks. Okay. Now, that in itself is not black magic. It is math and linear algebra. Okay. If somebody tries to teach you artificial neural network, they will explain it to you in the terms of mathematics and linear algebra. It is very, very explainable. But the problem is with the softwares that have been developed to solve these problems, right? Again, stepping back a little bit, machine learning suddenly became a rage, or AI became a rage somewhere towards the mid 2000s, right? Or late 2000s, I would say. But somewhere in the mid 2000s, another concept hit the industry, that is big data. We had never heard of the term big data 15 years back. Big data came somewhere in the mid 2000s. And with big data brought with it a couple of excellent capabilities. One is capability for massive storage. Second is capability of speed in processing. You could do things like this. So when I started my career, it would take not hours, but still it used to be a pain to work with large sample of data. So with big data, it became just a matter of seconds to process terabytes of data. This phenomenon of big data and the power of computing that it brought to the table is one of the factors that actually uh, enhanced or became a catalyst for the growth of machine learning, or especially the school of neural networks. It was very fast to do this. Uh, Another thing that happened, like I said, AI is all about text and audio and video. Okay, so this school of neural network, or the way it's being done now, uh, grew around this unstructured data. So a classic example, when somebody starts learning neural network, they're first taught to distinguish cats and dogs. That's a most basic exercise that you're taught. Okay, the focus was on classification, and there's also regression problems, but again the focus was on getting things right. It was about accuracy and less about explaining the model. Like I said, there are some of the old school machine learning models which are purely explainable, because there the focus was on explainability. 15 years back, whatever algorithms existed focused on explainability. Whereas from this mid 2000s, when neural networks became the new game of the decade, the focus was on accuracy. It was all about, have you got it right? How you got it right wasn't all that a concern, which is why this concern of explainable AI has come into the picture. Uh, and the way it is done, like I said, it is math and algebra, but the open source softwares that are currently used by mostly everyone to do a neural network, for example, hasn't developed a mechanism by which the the final model the prescription of the final model can be uh, sucked out or can be extracted and presented to an English speaking person, that I decided that this is a cat and not a dog because of these reasons. It is it doable? Yes, it is doable. But is it currently being achieved by the softwares that we are using? The answer is no. Which is why there is a concerted effort in the industry to make these sophisticated models, especially on the neural network side, explainable, because once you take it to a business, somebody has to explain this in English to executive members. That is not possible now. That is why this buzz about explainable AI.
Absolutely, and I think you made it so easy for us right now. So I I bet it's not unexplainable as you said. So moving on to my next question, Bindu, what checks and balances should organizations have in place to make sure they can trust the AI algorithms they're using?
Okay, so like I said, there is the problems organizations are facing is about around this factor that it is not explainable, right? uh, and before I answer your question, I would like to address another thing as to where this problem of explainability hits the industry. Which sectors does it hit the most? Okay, uh, banking is a sector where this is a real major problem. Uh, and the reason is this: banks are governed by regulatory and compliance network, and banks have to explain everything that they do with the customer's data. So I'm sure you would be familiar with recommendation engines. Like, you get it on Amazon. Like, so once you log in, Amazon tells you buy this, buy that, right? That's
Yes.
basically a recommender system, right? Most companies use that, and you can do that with any data. You can do with banking data also. So in banks, when you do a recommender system, it works the same way like in Amazon, and it will actually tell, like a call center agent, that you can try and sell this loan product to this customer. Okay, which is okay with a retailer. But in banking, especially in the West, right, there is this concept called mis-selling. If you mis-sell a product to a customer, uh, and that product didn't work for that customer, they can actually sue you. People do sue banks on terms of mis-selling. So when a bank gets sued because they sold a wrong product to the customer, when a compliance authority comes and asks them, why did you sell this product? They will say, my AI algorithm asked me to. You can't just leave it at that. You have to explain why this AI algorithm asked you to sell this product to Chandani. Okay. Until and unless your model is explainable, you can't go to a compliance authority and say it's a black box. I don't know what it does. It just told me to sell and I sold. You
Correct.
can't answer like that. Like you need to
Absolutely.
give a solid explanation, which is why there are certain sectors, especially governed by compliance and regulatory authorities, where this becomes extremely important. Okay. So this is for those sectors. I mean, the other sectors, which is not so much bound, but again, this is becoming increasingly important. Like in Europe, for example, they have the GDPR, where the right of a customer is protected. So even if it's a retail customer, they need to have an explainability when they do these recommender systems. So what can be done? Right? Like you asked, what checks and balances should organizations have in place, right?
Correct.
So that not only government authorities, but public can also trust. Mainly, business has to trust. The client has to trust that an AI algorithm developed by a data scientist is something they can trust. Uh, that For that, like I said, there are even now there are some of the uh, traditional machine learning models which is quite explainable. So it's a trade-off. But like I said, the accuracy of those old style regression decision tree accuracy is not so great. Whereas the slightly complicated, which is clouded by mystery algorithms, accuracy is great. So one thing organizations has to take a stand is a trade-off between accuracy and explainability. If accuracy is not a big deal, I have a bunch of explainable algorithms that I can work on, depend on, and explain to anybody who wants to understand why did I make that sale. Okay. So go with them because they are totally explainable. Yes, accuracy may not be like 95%. But if you want to go with the cloudy, unexplainable models, then that's a trade-off that you have to take. Okay. So have a clear understanding on what is your benchmark on the accuracy that you need, right? And how much tolerant. For example, I can tell you banks cannot be tolerant about this explainability. So banks might as well go with explainable models than the complicated, unexplainable ones. So that's a call every organization has to take, depending on their business and depending upon whom they have to explain to. Okay, that is one thing. Then one problem with machine learning, right, is that it's quite manipulative, and this is my personal opinion. Okay, don't hold any of my teachers or any of my past organizations or present organization responsible for this. uh, Data science is quite manipulative. The reason being, uh, it is in the hands of a data scientist what data you choose and what algorithms you choose. Okay, so I can bring to the table a kind of data which will tell me the story that I want to say. So there's a joke in data science which says that data analytics is nothing but beating the data till it tells the story that you want to hear. Okay. A lot of us do that at times. Sometimes you want a particular answer from that data. So you will beat the data this way, that way, till it confesses and say, okay, I admit this is what I am seeing. All right. In a way, that's how it can work. I'm not telling that's the way everybody does it. You can do it, right? So which is why you should avoid data bias, right? And for that, one of the best practices is to have an independent auditor. Like most organizations either do data science internally, or they will give it to an outside vendor, right? Whoever does it, in my opinion, you should have an independent data science auditor who can actually check. I mean, was there any bias in the data? Has this person, data scientist, consciously chosen a data which will tell him or her the story that they want to hear? Like, that is bias. You should avoid that bias. So that's a check and balance organizations can do. Have an independent data science auditor. And what will that auditor do is check for bias in data. You have a business problem, and for that business problem, if you think logically, you would know the right kind of data set that you want. Like, if you're trying to build a product recommendation engine, you should never take finance data. You should only take transaction data. So you do that check, and you should have individual level data, and your individual data should be masked, so that you do not understand who the person is, and it's a proper generalizable model. So these are things that in independent auditor should do to avoid bias in data. Then there can also be bias in algorithms, right? Like I said, it's you who choose an algorithm. And now there is this concept called overfitting in data science, right? That overfitting can be administered, and that's again what I call manipulative. You introduce thousands of features, or what we call independent explanatory variables. The more features you add, it will fit come what may. It's like throwing everything that you have into the box and say you pick up and choose and build a model. It will build the model. Okay. So that way, even without any business judgment on what you are feeding the machine or the algorithm, it will go and fit the data and give you great accuracy. And that is another thing why it makes some of these algorithms unexplainable, because it may be taking some gibberish feature and it will fit the model. And then if you're trying to explain, there is nothing there, because it's actually some random thing that it's picked up. Okay. So that is bias in algorithm, both in choosing an algorithm and choosing features. That is also something that should be 100% avoided. If a data scientist is not consciously doing it, if you have an auditor, that auditor can catch that. And that should be prevented. Like, organizations should not be using biased data, biased algorithms, or biased feature selection. Okay. That is one thing you can do. Another problem that happens with the models is, and I will take this to any equipment that you use. Okay. If you have a weighing machine at home, right? If you're weight conscious, I'm sure you would have a weighing machine at home. So the day one you bought it, when you don't stand on it, the dial will actually coincide with zero. You use it for a couple of years, you will slowly see that the zero position has shifted, right? So you will do that mental calculation. The zero is actually 1 kg. So if it's showing 35, then I should actually be only 34, right?
Absolutely.
You do that calculation. So this
Yeah.
wear and tear happens with any equipment, and this wear and tear happens with machine learning algorithms also, right? Why does it happen in the case of algorithms? Is because business change. Okay. I'll take a very good example. When COVID hit us, the forecasts of all organizations, all industry went for a toss because there was a new variable which nobody had factored in, right? It came out of the blue. So it threw off all predictions of every organization's sales forecast went for a toss. And so COVID was like once in a lifetime kind of thing, but generally such smaller impacts happen in any industry. Mergers and acquisitions can happen. Recession can set in. GDP of a country can go down. Buying power of people can change. There can be a strong competitor. So any of these subtle changes will impact the business. And you have developed your model based on some past data, which may or may not have factored in all of this. So as time progresses, to factor in the changes that's happening in the business environment, you really need to retrain the models with new data. So and like when I started my career, once in 6 months or even once in a year was okay. Business is changing so rapidly now. Like even once in 6 months is stale, I would say. So you really need to feed in more data and retrain it at a predetermined cadence at definite intervals, so as to catch all these surprises, right? If you don't do that, again, you end up with the same calibration problem with your weighing machine. And hence, and this is technically called model drift. Because if you start using a model which is old, right, like 6 months, 8 months old, you will find that accuracy is being hit. And that is one thing which most organizations do. So I wouldn't suggest as a checks and balance, because most companies which use machine learning will do that. They keep checking, is my prediction correct? Okay. For example, if you have a sales forecasting algorithm that's working, you will go and manually check it. Manually check it meaning you will compare with actual records once in a while to see if the machine, it's after all a machine, right? An algorithm. You can't leave your business to a set of codes. No business would be confident enough to do that. So people do go and check that occasionally. And you will see that over a period of time, the accuracy is dipping. You started with a 90% accuracy, and over a period of time, you'll see that it's slowly dipping. So when it starts dipping, it's a sign that you need to recalibrate your weighing machine, right? So instead of waiting for that, most organizations should, and that's what most people do, will define a cadence that I will retrain the model once in 3 months with fresh data, so that any of these surprises that has happened in the past 3 months, model will catch, and then your accuracy can actually improve. Okay, so that is something all organizations have to do: monitor their model drift and recalibrate their organizations, recalibrate their algorithms. So if an organization can do all of this, they're pretty much covered. Like they don't have to live with the fear of unexplainability and is it right for me to use AI algorithms? Because all said and done, data science is very powerful, right? And what a human being would take months to figure out, it can figure out in a matter of hours, or the development cycle is all that it requires. So it's foolish not to use data science, because like I said, it's not voodoo, it's not black magic. It is math and linear algebra, which is fun It's foundational science. It's not astrology. It is pure math. So if you don't take advantage of that, it's foolish, right? When you have a telescope to view the sky, why should you go into an astrologer's board to see where your stars are aligned? You just use your telescope and look at the sky. You use science, so you should use science. But this particular branch of science has its pitfalls. I wouldn't say it's a drawback. It's just that the softwares which we use have not yet reached that level, and it's an open source community, right? Things are happening. Like suddenly, people are realized that businesses need an English explanation. We call something called confusion matrix. That is what kind of summarizes accuracy of machine learning models. Data scientists are realizing business will not accept just that confusion matrix. They need English explanation. So there is research going on. A lot of companies are developing ways and means by which this bridge can be this gap can be bridged. It's just a matter of time. We will reach there. There is investments being made. There is research being done, and soon we will have. Even now there are some uh, softwares or some routines you can do to give a simple explanation. But it's not cracked the problem fully, but we will get there. So till we get there, it's foolish to say, uh, let it reach that stage and then I'll start using, right? Then your competition would have passed you by. People who are smart enough would have used AI and surged ahead. So no organization should do that. They should use data science, but have a balance between, especially if explainability is a concern for you. There are ways in which you can work around, right? But and have these checks and balances in place, you are quite covered from a risk point of view, from a compliance point of view, and you're in a good place to use data science for making your business decisions. That's what I would say.
That's really well explained, Bindu. So, as we were talking about machine learning, right? You mentioned about machine learning. Do you think that there are any other pitfalls of machine learning?
Uh, I think, I mean, somewhere I would have covered, but probably I'd like to call it out distinctly. Is that accuracy of a model, right? Accuracy of any machine learning model is totally dependent on quality and quantity of the data. Like I said, it's basically what data do you feed in that decides how good your model is. So generally, when I talk to business and they explain a problem to us, right? Uh, and generally they will ask how much data you need. So the moment I say I need 5,000 samples, like, so you suppose you are building something that can read a document and uh, understand, like instead of a human being reading a document, you can build machine learning algorithms that actually will read a document, and so that you really don't have to sit and read. You just have to scan it and give it to the algorithm. It will pick up all the information and put it in a Excel format or whatever format, CSV format, whatever you want. But when they ask how much data you need, like I would typically say I need a minimum 5,000 samples. That's when they'll throw up their hand and say, "Oh, stop! I don't have that much of data. I can max give you 500 PDF documents. That's all I have." Okay, you're sacrificing 500 upon 5,000. That's the accuracy you're sacrificing, right? You give me 500, yes, I can work on it, but don't expect an accuracy to the tune of 95%. You will not get it. So quantity is important, and so is quality. right? Like I was telling you, if you want to do sales prediction, and I ask you, give me past sales data for last 2 years, and you're telling me no, my sales data cannot be given. I will give you my budget data. I can't do sales prediction with your budget data. I'm asking actual sales history. And if you're telling that's confidential, cannot be shared, then sorry, we can't solve the problem. I can't use your budget data to do sales prediction, right? And
Correct.
I will ask that data, I will say that. And if you're telling I only have uh, state level data, like I aggregate it at, I have Karnataka sales, I have Maharashtra sales, I have New Delhi sales. But don't ask me store level data. I don't get store level data. I have only state level. Then I can only give you prediction at an aggregated level. So if you more granular the data is, better it is. Like, which is why if you work with people in the West advanced countries, where every customer, even in a retail store, they'll have these cards. Like every customer's transaction gets recorded. I mean, some random person walking into a Kmart may not have details, but generally you will have a card membership, right? So it's for a data scientist, it's a beautiful thing to work with more granular data. So more granular the data is, the more better the model is, more confident the data scientist will be, and more explainable it will be. And more the merrier. Data also. More data you give me, I'll be able to fit a very good model. So this is another pitfall, meaning a lot of people in business don't understand. So they give you the strange look, and say and they usually use this thing. Your machine should learn by itself. Why are you asking me so much of data? So that is a that's a, yeah, pitfall, I would say. That's something people should be wary about, right? It's not a black box. Quality quantity data, and it is data science. It's not magic. It's not magic, right? Data has to be given. You apply science on top of data, and you get the magic out. So quality and quantity of data is extremely important. Another thing, and I think this is a misnomer. A lot of people don't get this correctly. Uh, a machine or a machine learning algorithm is only as smart as the person who created it. Or I would take it a step ahead and say it's only as smart as the data that you have fed it. Okay. And I'll take the basic example of cats and dogs. You have developed an algorithm to distinguish between cats and dogs, it to the perfection of 99 percentage. Okay. It will now classify anything that you give it, a cat and a dog. You feed a picture of kangaroo, most likely it will come back and tell you it's a dog, because kangaroos have their ears up like this. uh, or it can even actually classify it as it's actually to be classified as a cat, because I think cats have ears like this. But it is not intelligent enough to come back and tell you that this is neither cat or a dog. It should say it is a different species, or it should say this is actually a kangaroo. A machine learning algorithm will never say that. It is not smart because you have not taught it. You have never introduced this category called kangaroo to it.
Correct.
Until and unless you have done, it doesn't know. It's only as smart as you have taught it to be smart. Okay. Because that's also another thing that I find when I talk to people in business. They'll say it's a smart machine, right? It must be smart enough to understand that it's a kangaroo. No, it is not. because I haven't taught it to be that smart. Whatever smartness I have given it is all smart that it is. So that is also a pitfall and that's something I think people in business should understand, that it is not replaceable. It cannot completely replace a human being. So it is only as smart as you teach it to be. Okay, so these two things are, I in my mind, are the major two pitfalls other than what we talked about of machine learning.
That's that's absolutely well said, and I really like the example wherein you explained how it cannot differentiate more than it has been put and the information has been put. That's really on point. So, thank you so much, Bindu, for giving us your time. Your insights were really, really valuable, and I know our audience is going to enjoy this interview.
Thank you so much for giving me the opportunity to talk to Engati.
Absolutely. So, before we wrap up with the interview, Bindu, are there any other thoughts you would like to leave our audience with?
Yes, yeah, and it's slightly connected to the one that we just explained, but and I find this very humorous. So I think I leave you with that thought. See, like and because there is this, and it's a purely my personal opinion. Okay, there are gurus in this field who think otherwise, but I honestly don't think machines will one day replace human beings. That's a fear that's also a hot topic of conversation people have, right? Will machines replace human beings? I don't think it will. And I'll go back to the cat and dog example. Okay, to build an algorithm like that with 99% of accuracy, you have to feed this algorithm thousands of samples. You have to probably to especially to get a 99% accuracy, you have to give millions of data points, like if not really millions, but at least 50,000 both cats and records type of observations. You have to feed it to get a really good model, right? Maybe there are smarter ways of building it with less sample, but definitely you have to give enough samples to make it distinguish. And you spend a whole lot of development time on it, like a month time, or like 4 to 5 weeks time of development effort is needed for a machine learning algorithm to distinguish between a cat and a dog. Okay, if you have a kid at home, Chandani, like a younger child, or a sibling's child, or whatever, whomever, right? A 2-year old kid. You teach that kid, you show a cat once and you show a dog once and tell that, beta, this is a kid, this is a cat and this is a dog, right? This is these are two different things. It takes less than a minute for that child to understand the difference between a cat and a dog. It
Correct.
doesn't need 25,000 samples. It doesn't need 5 weeks of training and validation for a 2-year-old to understand the difference between a cat and a dog. And tomorrow, if you show it a kangaroo, it will tell you that this is neither a cat nor a dog, this is something else.
Uh,
And it will
Correct.
never mistake a cat for a dog. Its precision is 100%. It doesn't need millions of sample or development time for you to teach a 2-year-old kid the difference between a cat and a dog. So that's the thought I will leave you with. A 2-year-old kid is much more intelligent than a convolutional neural network to identify the difference between a cat and a dog. I leave you with that thought.
Absolutely amazing, Bindu. This I have enjoyed the interview, and I'm sure the people who are going to watch it are going to love this one.
Thank
Thank
you
you
so
so much
much.
for this.
Talk to you later, Chandra.
So we'll be back with a new episode and a brand new expert soon. So stay tuned, and we'll see you around for the next one. Thank you.